Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Now today's topic is one of the topics in chemistry that falls under the concept of organic chemistry, and this is the concept of organic synthesis. Now this particular topic of organic synthesis basically is an aspect that is going to entail the concept of coming up with new products, specifically through manipulation or trying to transform the molecules that are already in existence. And we're going to see that this particular exercise is carried out in laboratory. Now, from the two product definitions of chemistry that we had looked into, we had said basically that organic chemistry deals with the structure and properties of substances that contain this particular element. Now, in our broader discussion, we had talked about the different characteristics of carbon that enable it to form a wide range of compounds ranging from branched chiral compounds and complex compounds, etc. Now, in this particular aspect, we're going to see that these particular compounds that are containing carbon can be transformed to achieve their analogous forms or different types of other complex compounds. And this basically is going to form an essence of our study for today. Now, as we had said that this aspect of organic chemistry, basically, if we try to give it an historical context, we're going to see that it's derived from the concept of living organisms. And basically, it was the concept that was dealing with the study of compounds which were extracted from living organisms, or what we basically can refer to as natural products. So in a sense, this one gave a particular sense that this particular products that were were under the category of organic compounds basically were derived from living organisms and natural products, and therefore there was that belief that these particular compounds could only originate from these two specific sources. Now, the development in science at a particular point in time came up with an idea that was contradicting this specific belief, and we're going to see that this basically formed a basis for the development of the concept of organic synthesis. Now, from definition, we're going to see that the concept of organic synthesis basically falls under the category of chemical synthesis. So in a sense, it's a branch of chemical synthesis, which also is an aspect that describes the physiochemical transformations which occur, whereby we find that two or more similar, this is legible. So the aspect of chemical synthesis entails two or more similar units. In this sense, when I talk about units, I refer to as maybe molecules are joined together to form more complex ones. So basically, organic chemistry, or rather organic synthesis, is a sub-branch of this chemical synthesis that is a process of transforming similar units by joining them to form complex ones. So therefore, we are going to look at this particular discussion in that specific sense. Now, I had mentioned the concept of the historical aspect of this concept of organic synthesis. Now, if you try to have just a short or a brief discussion on that particular case, it is true that humans have always endeavored in this particular aspect of the art of trying to transform what we refer to as matter. And in this particular case, it is due to the aspect of necessity, whereby we find that we have to prepare food. And therefore, in that particular endeavor to prepare food, the human endeavor has been to try to transform different aspects of matter in order to form what we refer to as food. And then next, there was the need for having the medicines in order to keep the diseases at birth. So therefore, the aspect of trying to prepare medicines entailed the transformation of this particular aspect of matter. And there are different drawings and perhaps decorations that we encounter in different timelines in history. And therefore, these dyes were due to preparation of different aspect of matter in order to form these particular dyes. And therefore, we are also going to look at in the formation of tools and weapons. We're going to see that there are different aspects of matter which were involved and different transformations which basically led to achievement of this particular aspect of life. Now, throughout the civilizations that we can be able to identify in history and other, maybe a few examples that we can mention, like the Egyptians, the Babylonians, the Romans, the Greeks, the Chinese, etc. We're going to see that throughout these different civilizations that we can be able to see, we're going to see that these different aspects were being practiced in various ways, and there are several evidence trying to back this particular aspect of trying to perform different transformations on matter, especially when it comes to the last three part of what I've already mentioned. So therefore, this is going to give us a basis of trying to see that this aspect of trying to transform matter, or rather some chemicals, as we can say, started a long time ago. But however, during this specific period, there were no specific ways in which they could be able to try to describe these specific transformations. And therefore, at some particular point in time, there were some experimental procedures that were developed, or rather what we can be able to say as some procedures that were being developed in order to try and describe these various transformations. And this basically had a significant effect on how this particular concept of trying to transform matter was being perceived. Now, a specific example that we're going to see is that for about at this particular point in time, we can just give it just an approximate. This was around 425 BC, where we had some great philosophers like Democritus. Democritus had tried to describe the concept of atomic theory, and we have looked at it in one of our videos on the introduction to the concept of an atom. Now, Democritus came up with the concept of atomos that was describing the concept of an atom. Now, from this time of Democritus, it took a period of around 2,000 years for other scientists to come and arouse this curiosity of the development of some aspect of an atom. And therefore, we can see from this specific time the advent of Dalton. We're going to see that J.J. Thomson and also others like the present understanding of this particular aspect of matter, like the Niels Bohr and Rutherford and other various scientists who came up with the ideas that back the present understanding of the subatomic level, or that small aspect of matter. Therefore, from this particular case, we're going to see that packed up with some scientific procedures that we're going to just roughly call experiments. They packed up the evidence of these particular chemicals at a very small level, and therefore it shed light on how we are going to perceive how these particular chemicals are going to interact. And therefore, from there, we are going to see that now the concept of organic synthesis is going to be developed, whereby having understood the structural formation or makeup of these specific molecules at the subatomic level, therefore we can be able to detect movement of the subatomic particles like electrons, and the rearrangement, subsequent rearrangements which are going to occur, especially when they interact in what we refer to as chemical reactions, or rather the transformation that I'm talking about. So therefore, basically from this particular sense, then therefore we can be able to say that this aspect of organic synthesis refers to the art or science of replicating molecules of we can be able to say the science of replicating molecules of living, we can say living organisms or natural products, And now in this case, we are going to see that this is going to lead to the formation of similar molecules or their analogies. In order to form similar molecules or their analogies. Now, analogies which are, of course, going to be similar, or maybe some kind of derivatives from this particular sense. So this is going to refer to an art of science of replicating molecules of living organisms or natural products, which are going to form similar molecules or their analogies. So in this particular case, then therefore, we're going to see that this particular practice has found wide applications in our present society, whereby we are going to see that it's being applied in science and technology, especially in the concept of medicine, pharmaceutical industries, the dye industries, the agro-based industries, which are agrochemicals, etc. So therefore, this is, brings the aspect of this particular organic synthesis in our present application, and this is going to assist us appreciate this particular topic from that particular sense. Now, having given this specific concept of organic synthesis, historical context, and some of its applications that we have mentioned shallowly, we're going to see that basically we can be able to pinpoint a particular point in time whereby this particular practice of trying to synthesize organic compounds started. And this basically, as I said, of course, this can be able to be traced way back. But in this specific periods that we have talked about, there were no significant ways in which we can be able to address these particular steps that were being performed to transform this particular matter in a sense. And therefore, as we had said that it was believed that only living organisms were able to create organic compounds. The above idea was, of course, changed during this specific period, and this is the 19th century, whereby we're going to see that this German scientist, of course, by the name Friedrich Wöhler, performed an experiment that resulted in the formation of urea. And this urea is a natural product, and therefore this gave us a basis in a sense of trying to perceive a new way of trying to come up with this specific product. And the formation of this specific urea, this opened a window for a transformation of various chemicals to come up with new products, and perhaps try to find solutions with to some of the challenges that the society was facing. Now, Friedrich Wöhler performed an experiment whereby he reacted silver cyanide. This is a silver cyanide, and together with ammonium chloride, and the product that he obtained from this slowly heated it in that particular subsequent procedure, and then this led to the formation of what we call urea, contrary to the product that he had expected. So therefore, as we have been always doing this one, we can be able to give it an equation so that it gives us a visual, perhaps we can be able to visualize how this transformation was able to be achieved. So this is the reaction between silver cyanide and ammonium chloride, and this led to the formation of what we call ammonium cyanide that was further heated to produce what we call urea. So this, I'm just going to write this one, but give it a formula such. So we're going to have this carbonyl carbon at this specific point being joined by this amine groups given as such. So therefore, this was the final product after heating. So the first step was the formation of ammonium cyanide from this particular reaction between silver cyanide and ammonium chloride, which later, when you performed this particular procedure for heating, therefore this resulted in the formation of ammonia that I've given in this particular case. Now, since this one was considered to be a natural product and it has been achieved in this specific procedure, therefore this gave an idea that other elements can be achieved, or other compounds can be achieved from this specific procedure. So therefore, in our study of organic synthesis, this is going to open for us a window of trying to find ways in which we can be able to achieve the desired products using specific reagents. And therefore, we're going to see different conditions being having an interplay in order to lead to the formation of desired products. And therefore, later we are going to see other step-by-step procedure or step-by-step a sequence of events that we are going to refer to as mechanisms being illustrated into formation of different products. So therefore, we are going to refer to those ones as their reaction mechanisms, which are also going to, in a sense, be part of this study of introduction to organic synthesis. Therefore, in our study of organic synthesis, we are going to emphasize from the concept of organic, we are going to emphasize on the concept of carbon, which basically forms the basis or a basic element in this particular branch of chemistry. So therefore, we're going to look at different bonds that we had mentioned in our introduction to organic chemistry, which we said that due to the diverse characteristic of a carbon are going to form covalent bonds with this specific carbon. We said that carbon can form a bond with another carbon atom, and then we said that carbon can form a bond with oxygen, sulfur. We had mentioned other carbons bonding with nitrogen, etc. And basically from this particular case, we had mentioned that there are specific parts of an atom which we had called functional groups. And from our concept of organic synthesis, we're going to see how different functional groups interact to come up with new species of chemicals. And from this particular case, therefore, we're going to consider the concept of what we refer to as reactivity, which is, as I can roughly say, is the readiness of chemicals or the nature of chemicals, which is going to allow it to interact with various range of other chemicals. So in a sense, I've mentioned the concept of functional groups. Therefore, we are going to consider the basic functional groups that we had started to discuss with in our introduction to organic chemistry, and that is alkenes and alkynes. Now, we had said that alkanes have actually a class of organic compounds which show very little aspect of reactivity. Therefore, we are going to consider these two specific groups of unsaturated compounds for alkenes and alkynes in this particular discussion. Therefore, I've said that these compounds are what we are going to rely on, especially in our start. And therefore, we're going to see that from their physical and chemical properties, therefore, we're going to see that these particular compounds are normally reactive in the presence of acid, or what you call, so they are reactive in the presence of acid. I'm going to use this particular description or notation for a proton, just the presence of an acid or a metal. And in this case, we're going to give an emphasis for the transition metals or transition metals, so that we can be able to just use the specific ones in this particular case as we go ahead. So therefore, we're going to see particular reactions of these two classes of organic compounds for alkenes and alkynes specifically by giving the various equations and try to see how we can be able to transform them into other compounds of our desire. So suppose I give one of the examples, especially for the addition reaction. I decided that organic compounds in one of our videos can undergo different kinds of transformations or reactions. Among them, I mentioned the case of elimination, addition, substitution. I said about the rearrangement and addition reactions, etc. So in this case, we're going to look at one of the examples of addition, an addition reaction, whereby we are going to react an alkene with what we call water. We had talked about the concept of a hydration reaction in one of our videos. I'm going to put a link in the video below so that it complements in this particular discussion. In any case, if one of us need to find out in details how specific reactions that entail the concept of organic compounds and water work. So if I have a compound, this is a 3-carbon compound which is alkene, and it's going to interact with water. I said that these compounds interact or perform normally reactive in the presence of an acid or a transitional metal. So therefore we're going to have this particular compound reacting with water, and this is going to lead to the formation of what we refer to as an alcohol, which we're going to name as, from our nomenclature, this is going to be 2-propanol. So therefore, if you want to transform an alkene into an alcohol, it will undergo this process whereby we have said it it reacts in the presence of an acid, and we can specifically give this one just sulfuric acid as such. So therefore, this is one of the reaction a way in which we are going to achieve this functional group for alcohols from alkenes using this condition of an acid by addition of water. So therefore, this is one of the ways which we can be able to synthesize an alcohol from that particular case. And we're going to see that the presence of a water and acid is going to form what we refer to as a hydronium ion, whereby this is going to have a reverse reaction, whereby we're going to have this hydronium ion having that formal charge of a positive given as such. So therefore, if we try to look at the series of or the sequence of steps this particular reaction is going to go through to form the final product, we can be able to illustrate this one using this particular example, whereby the water together with the acid form hydronium ion. I mentioned about the concept of electrophilic and nucleophilic aspect in this particular case. So therefore, in some cases, we're going to consider the aspect of a nucleophile or an electrophile whenever we are trying to talk about this specific reaction. So we can just be able to expand this hydronium ion and give it as such, whereby that formal charge, which is positive, is going to be shown at that particular point. And if we try to look at the forward and back reaction, we can be able to use such specific arrows in order to show that the forward reaction is going to be favored and the end product, which is a reverse reaction going to the left, is going to be favored, but to some degree. So that is why I've used those two specific arrows, which are not equal. If we try to look at them from our aspect of vectors, this is just bigger than this one. So therefore, which means the forward reaction is going to be preferred more than the reverse reaction, which is going to occur. So this is going to lead to the formation of what we refer to as cation, which is going to be given as such, and then there's going to be a product of water as well. So if you try to look at this, a carbocation is an intermediate species which is basically not stable. Therefore, it's going to interact with this specific hydronium ion in order to form the final product. So in this case, this is going to be transformed into what we had mentioned as another intermediate product, of course, which is not the final product, which is going to be illustrated as such. So therefore, the water molecule in this specific case is going also to interact with this particular intermediate species by attacking that specific positive or part, that specific, no, this one is basically going to pick this proton at this specific point, pick the hydrogen at this specific point, and this is going to move in order to stabilize that particular charge, and therefore this is going to result in the formation of a secondary alcohol, and then plus a hydronium ion due to the interaction between these particular lone pairs of electron and this hydrogen from this specific point. So therefore, these are going to be the products which are going to be formed, which is the product given for 2-propanol. 2-propanol, this is 2-propanol together with the hydronium ion that is going to be formed. So in this specific case, then therefore we're going to see that this particular sequence of steps as what I basically referred to as the reaction mechanism. And in our discussion that we have had for this particular case, then therefore the subsequent discussion that we're going to have, of course, are going to be more specific as compared to this first discussion, whereby we needed to introduce the concept of organic synthesis and other aspects that were necessary for us to understand this specific topic. So therefore, in our other discussions, we're going to look at different ways in which you can be able to synthesize these different functional groups, or come up with the various functional groups from the specific ones that I've mentioned using different reaction mechanisms and some of the conditions that I've mentioned, like the presence of an acid or transitional metals, respectively. So for now, we'll have to stop our discussion there. Catch us in our next video, where we're going to look at the specific products which are going to be formed from the interaction of alcohols or different functional groups that I've mentioned, basically from this particular wider range of organic compounds. So that is it for now, guys. Bye. God bless you.